2014. I would now like to turn the conference over to Raphael Newt. Please go ahead.
Thank you so much, everybody, for joining our latest episode of the OpenStack online meetup. Today's topic is, what is Trove, the database as a service on OpenStack? Trove was integrated into IceHouse release of OpenStack to provision and to manage databases in an OpenStack Cloud. And with Trove, developers can spin up a database instance on demand in an instant. Today's presenter will be Ken Ruck, the CEO and founder of Tora. And with that said, let me hand over to Ken. Ken, the stage is yours.
Thank you very much, Raphael, and thank you for having us here and for all the folks who are joining. We're looking forward to explaining to you a little bit about Trove and our participation in Trove here at Tora over the past year or so. And so we'll go ahead and get started. So first of all, I think one thing is when you look at Trove and you look at why are we building a new database infrastructure, is to understand a little bit about how the world has changed and the transformation to cloud data management over from where the market has been and where IT has been in terms of managing data. And certainly there's been a lot of innovation and changes in the way people have built database servers. And you see that in NoSQL, and you see that in many of the parallel database technologies and NewSQL. But there's also been a real transformation in the needs for people managing those databases as well. When you go from traditional IT to the cloud, and in the old days, was the DBAs were responsible for if you wanted a database, you'd talk to your DBA, and maybe 2 months, 3 months later, they'd have a machine set up for you, and it'd be all configured and optimized, and that really doesn't fly in the world of Amazon, and where people are expecting just to very simply get a database server up and running and have it be managed and ready to go very quickly. That role of the database management specialist has really become much more minimized in many cases, where developers are kind of, because they can't get necessarily the abilities of a new database very quickly and meet their needs in terms of the agility that they need, they're going off and managing those databases on their own, and maybe in the right way, maybe not. So, again, there's a need there for a gap of making sure these things are being done properly. Another thing is really key is that when you look at the old style of databases, they were Oracle site licenses on big iron machines, and that was kind of you'd have any large IT organization, typically you'd have an enormous footprint of Oracle, and it was all the same, and there's homogeneity there, and now in the new world you're dealing with all the NoSQLs, and if you're trying to find the best tool for the job, and there needs to be a new infrastructure in order to allow you to manage that and to be able to cope with that kind of those kind of environments, and really and also finally it's kind of the old world of the captive audience, and where if you wanted a database you did have to go to IT, and those guys were responsible for it. Now there's the whole new world of shadow ops, and if a developer needs to provision a database, he can just get on the AWS website and spin up a database, and in minutes later, he's up and going. And so IT has to really respond and address that and build database as a service into their own meaningful world. And again, you see the graphic here. I mean, I think it's a little bit analogous to old style telecommunication provisioning. There's a hard wire connecting to the wall to now the world of bring your own device, and you've got much more flexibility. Everybody's got a different set of capabilities. Again, I think we've moved on. So when you look at that, what we need is something that looks a little bit more self-service, a little more dynamic, a little bit more play as you go. And Trove gives you that, and that's really the focus of Trove. It's to try to give you database as a service for OpenStack. Again, there's an OpenStack call, and certainly Trove is one of the major projects of OpenStack now, and it's all about delivering you full. Some people call it database provisioning and self-service provisioning. It certainly does that, but actually it goes beyond that too, and it gives you full database lifecycle management across many databases, both relational and non-relational here. You can see that also in the Trove mission statement, right? to provide a scalable, reliable cloud database as a service for provision and the function of the databases. Again, its goal is to going back to that first slide. It is trying to meet the needs of the new IT environment, the new world where developers are expecting a real self-service experience and the ability to get what they need on their own without having to have a lot of interaction, a lot of time delay by dealing with a lot of IT and IT bureaucracy potentially. So, again, some of the highlights of Trove, first of all, one of the things when we look at Trove, it was very much designed to run on OpenStack and take advantage of the OpenStack environment. So, again, it takes advantage of Nova, it takes advantage of Neutron. It stores its volumes in Cinder. It looks, it will do backups to Swift. So, sort of again, built on the underlying services. So, as opposed to trying to reinvent the wheel, it makes it very easy to quickly spin up relational databases and non-relational databases, as I mentioned before, and simplify a lot of the mundane administrative tasks. And also, I think a key thing is to make those administrative tasks, make sure they're being done in a consistent way. And I think that's one of the things we found is that that consistency is something that in the old world of everybody just uses Oracle and we have a site license and the DBA takes care of everything for you, to the new world of everybody's got a different database, it puts a lot of challenges on the organization to ensure that things are being done consistently, and ensuring that you have backups, ensuring that you've got availability options and replication and things like that. Again, the goal of Trove is to bring a consistent quality of service to the world at large. So digging into that a little bit and looking at kind of how the Trove architecture fits, I mentioned that it is part of OpenStack, and it is sort of going beyond to how a lot of the OpenStack. One of the things I often talk about with people is that they think of Trove a little bit like Swift or a little bit like Nova or Cinder or something like that. I think something that we've found in becoming involved with Trove and working on the project is that one of the things that's actually a little bit different is that it's actually layered. It uses a lot of the underlying services. So it's almost like, kind of the next tier up from infrastructure as a service, moving towards platform as a service. Because if Trove needs to start up a database, whether that's a MySQL instance or a MongoDB instance or what have you, it goes to Nova, and it asks Nova to spin up an instance. It gets an image. The image is being stored in Glance, and Glance is kind of your directory of where to find that image. It will need to have volumes in which to store your data, and that goes to Cinder. And then, if you do a backup, it will talk to Swift, and the guest agent in this case will be talking to Swift to actually ensure that it's doing the right thing to do the backups. Internally, again, a lot like a lot of the other projects and use cases within OpenStack, it's an asynchronous protocol. It's using web RESTful API, but it's using a message bus, so you can manage these things asynchronously, so you can have a very scalable service, which is again key for many of the people who are using this kind of capability. Another key thing, I talked about the guest agent. That is actually a very unique thing, and I think one of the very interesting things about the architecture of Trove is this multi-data store architecture. And again, a lot of times, and I'm sure some of you are familiar with Amazon Web Services and the Amazon RDS, I think one of the things that's actually very different about Trove, and things that's very exciting, is actually it provides one common infrastructure under which you can manage many different database architectures. So it's not just relational, it's not just NoSQL, it could be data warehouses. It could be small instances running in VMs. It could be, in time, how do you connect to large database servers and multi-tenant servers in the case of an Oracle or something like that. encapsulation of all the database-specific capabilities into a module called a guest agent, I think is very powerful, because it means that the Trove controller, which provides the database agnostic code, which says, I want to do a backup, I want to have replication here, I want to be a manager, I want to set the configuration of my database. All that can be done in kind of a data store agnostic way. And data store is kind of what Trove is, the word Trove would use to describe a database vendor's specific database server technology. So that's the Trove controller basically is giving you a standard way of interacting with these databases. And then under the covers, each of the guest agents can provide kind of a best-of-breed quality of service to each of the individual underlying data stores. So, again, the way that MongoDB does backups, the way that Cassandra does clustering, the way that MySQL does things are all going to be a little bit different under the covers, but at least you have a common metaphor, so you've got some way of creating a level of consistency for the database administrators, which I think is really valuable there. And again, I think even to the point where you'd say in some cases, the guest agent for MySQL, maybe you have different specializations, different types of backup that you might want to use with MySQL. So it's not there can even be specialization in database versions or different types of flavors of the database that you're using in this case. So that's again, I think this is one of the really key things that makes Trove very powerful and very flexible for someone who's implementing database as service in their enterprise. Go on. So one of the things in terms of managing Trove, I think Trove is a number of different things, and I think this is key. Again, as I said, a lot of times people say, well, it's just provisioning, isn't it? Well, actually, it's a lot more than that, because what it gives you is a way of kind of some key things. One is the management, the basics of management, the administration. How do you do provisioning, but how do you set permissions? How do you need to enable a root user? Do you want to prevent the root user from accessing it? How do you resize the volume? Coming up with a different flavor of the instance size. How do you do backups? Again, all the life cycle of your data and managing that life cycle. Another thing is key, I think, is the ability to do tuning. So automatically setting the parameters and kind of setting some sane defaults in there is really key. And then also, I think one of the cool features is the notion of a configuration group. Configuration groups let you kind of en masse change the configuration. So if you want to increase the number of connections for your MongoDB instances or your MySQL servers, you set a configuration group, and then you can go in and you can quickly change all the parameters within all the servers that are within that configuration group. So if you had a particular class of server that you were using for web hosting or something like that, you could go in and change that configuration to optimize it, en masse, as opposed to having to go and configure each of those servers individually, which again gives you better consistency, better ways of making sure that all of your servers are going to be set up optimally, even as that changes, even as it may change over time as you learn new things. Of course, it also manages security and being able to turn off SSH, being able to manage security groups, get rid of anonymous users, things like that you can and actually apply patches automatically. I think those are all kinds of things that again, managing the life cycle of the data store is really means a lot more than just provisioning, and between management, tuning, security, all key elements of what Trove can actually provide. Another common question that we see when people are talking about Trove is, is this actually being used? And to that I say absolutely. It's something that's actually in production deployment at a number of places. Again, right now it is, Trove is still fairly early. It was introduced in IceHouse as an integrated project. It was first incubated in Havana, but it's with these folks. These are folks that are actually contributing to the project and are very active between eBay and HP and Rackspace. HP and Rackspace both use it as the basis of their public cloud database as a service capabilities. And eBay actually has an internal database as a service facility that they've deployed, and they're using it for both for development and tests, which is actually quite common for people to get started with Trove these days. But they also use it for some of their production systems as well. I'll just put in a plug. We actually had a Trove Day conference about a month or so ago, where we had some really great talks. So actually, up on our website, we'll give you the information about how to find this later, and we'll have the links there. But actually, eBay was able to present, HP as well, talking about how they've deployed and how they've deployed Trove into these production workloads, which we found it was really great to have them be able to present those use cases when we had our Trove Day recently. Moving on, I think one of the other things is good to look at is kind of the use cases. And one of the things I'd say is key early use cases, because a lot of times when people are adopting database as a service, they say, well, do I just move over my SAP implementation to Trove? And I generally no. Usually you're better off setting things up so people can get used to the new world of how do I do self-service provisioning and how do I set up servers. And that's a great place to do that's in development and test. If a developer needs a new database server, or if the QA group needs to spin up 100 servers for some scale testing or something like that, Trove creates a great way of doing that, because developer, they've got the UI, the graphical UI, part of Horizon, to communicate to it and operate on it. It's set up easily, spin up servers of many different flavors of databases. Or if your developers, if your testing infrastructure can use the APIs to spin up servers. Web applications is another very common early use case, as is on-demand analytics, and that's almost a very similar use case that many of you may have seen in the use of Hadoop, where people may want to spin up many or just a few database servers, relational database servers or NoSQL database servers, where they want to spin up a cluster of servers, run a bunch of analytics, import a bunch of data, run some tests, some queries, and then tear it all down. Again, because Trove is managing the full life cycle, you can easily spin up servers, tear them down into a virtualized cloud environment without a whole lot of gnashing of teeth beforehand to make that all work. And again, the critical capabilities of the self-service and multi-data store support really help enable that. I think that's really key. I think, again, I mentioned this earlier in terms of Trove, incubated in Havana, and then integrated in IceHouse, supporting, initial support. Early days in Trove, MySQL was early, and MySQL continues to lead, in terms of the capabilities that are there. But there's a number of other databases supported now that were both in IceHouse, and then in Juno, the upcoming release later this month will actually add replication for MySQL. That's replicas for MySQL replicas for scale out and read replication. Clustering, the first implementation is for MongoDB, but also there's work being done there for Couch and others. And it's also the first iteration where we're delivering Postgres support. Then when you look, so a lot of, again, I think one of the things I'd say is it's been a lot of acceleration in the development of Trove. So once it became integrated in IceHouse, a lot of, that had to get a lot of I's dotted and T's crossed, as we say, to get there. But now we've, delivered a lot of new capabilities in Juno that are showing up. And then for Kilo, additional, lots more. So additional replication work. There's going to be replication v2. Clustering capabilities will both be enhanced and delivered on a lot more of the data stores. So there's work going on a lot of the other data stores. I mentioned Couch being one of those that we're working for, and then adding data stores as well. Looking ahead, there's also, I think, when you look at some of the investments that we're making as a company and the Trove community in general, I think one of the big places we're seeing a need is expanding on the enterprise capabilities, whether that's the security and monitoring and billing types of capabilities, or just support for some of those traditional databases. Again, a lot of times the first database you support may be the MongoDBs or MySQLs, because those are where your greenfield applications, your new application implementations are happening. But over time, as more and more applications get migrated into the cloud environments, we're seeing needs for and requests for some of the more traditional enterprise class database data stores. And again, I think one of the key things when we look at it, all of that, what makes database as a service and Trove really unique, and I think it is something where, and why is it different from a lot of the other services that happen and are supported by OpenStack? You can, again, as I discussed earlier when it's showing you the architecture, Trove uses a lot of those underlying services. So therefore, you can certainly spin up a Nova instance and run a MySQL server on it, but you're kind of missing out on a lot of things. And kind of databases, I think, are different than a lot of the underlying base supported, because they benefit from the management skills and DBA skills that bring to bear a lot of the consistency and resiliency of how you manage database, and that's something that you see as they grow out, as the capabilities grow in Trove. And then I think Trove is different as well because, again, leverages those underlying services. It's not kind of standalone and is an island like some of the other basic services of OpenStack. It lets you customize and tune the images that are there that are built for each of the individual guest agents and guest servers, and provides a way of delivering a very consistent management across the board. So that's again, I think that's what we're trying to do as Tora. It's trying to give you that the benefits of Trove in this world. And again, when you look at what we're doing, actually we're delivering, and we'll talk a little bit about our enterprise database as a service platform that's based on Trove. We have become, since we've become active in the community and we've become the #1 contributor to the Trove project actually during the Juno cycle. We've got 10 developers in the project, and one of our team members, Amrit Kumar, our CTO, is actually on the Trove core team. And I think one of the things that's been really great about participating in the Trove community as a company coming into this was that it's a really diverse community. It's a lot of great participants. You can see here we're the #1 contributor, but it's not because we're doing 90% of the work. We're in there as a team with a lot of the other guys, and I think this is one of the things that makes OpenStack overall great, is this kind of a diverse community, and it's something that makes Trove great because we are a team, I think, bringing something unique, because as a company we are really database product specialists, and we're our DNA is we've built database servers in our past lives and database replication engines, and we know a lot about the importance of transactional integrity and the key elements of database management. But at the same time, we as a team had not necessarily managed tens of thousands of servers running database servers before. And that's when we can participate in that community with the HPs and the Rackspace of the world, where they're running public cloud database as a service. It's been a really great collaboration where we can learn things from them, they can learn things from us, and we, I'd say, one of the things that's been great in joining the OpenStack community and the Trove community in particular is that we've really been welcomed with open arms when we started investing in this and really jumping on board and working on Trove. So that's been really great. So I think, that you can see, we've made a really sincere effort to be, upstream first and push a lot of the work. The replication work that I mentioned that came out in Juno was a project we led and really did most of the work for. But again, it's the ability to work, kind of shoulder to shoulder with some of these great companies has been really a pleasure for us in terms of contributing. Again, expanding on that a little bit to say, kind of what is it that we do as a company and where we, what do we actually do? What is our business as Tora? We are, first of all, again, as I said, a lot of the work we're doing is upstream first, and we're really focused on doing that. But some of the things that we see is and one of the places where we're doing that is in our Trove Community Edition. And that's freely available. You can get that on our website and download that. And part of the community edition is really to stay true to Trove and really keep it as standard Trove kind of through and through, but at the same time make it a little bit easier experience in terms of adopting that. So, again, we've added scripts for installation and maintenance, making it easy to install whether you're using Red Hat or Canonical or what have you, making it easy to plug into any of the existing environments, and kind of rounding off some of the rough edges was kind of our goal there, was to make it easier for enterprises. Again, we talked about the fact that some of the early production deployments of Trove are also being done by the guys that are contributing to the project. We wanted to make it easy for everyone to adopt Trove, whether you had people on your team that you could really dedicate to contributing to the project or not, and kind of lowering the bar a little bit there. Moving beyond that, we've also recently introduced our Enterprise Edition, which adds a bunch of enterprise features. We accelerated the support for replication and clustering into that release, so we made that be available earlier than it came out with earlier than the Juno release. So that was something we can accelerate some of the upstream work. And then also sometimes when another key investment we've made is in the guest images. Again, I mentioned one of the big things about Trove that makes it very unique and powerful is a specialization for the guest agents and the way we can kind of isolate the database-specific capabilities into those guest agents. Well, guest images are kind of the next step beyond that, where we're actually creating an image, a machine image that you can deploy into your OpenStack Cloud using Trove that actually is optimized for a specific data store. And it's sort of both the configuration is optimized. We've built that up, and you can just simply download that from our site to get full capability there. Again, I mentioned the life cycle and the fact that we are very active, doing the upstream development. We at the same time we're managing kind of a full, typical open core product life cycle here. Is building some specialized features in the enterprise version that may be high value, but for some very specialized use cases. That the community, again, a lot of times those kind of specialized features are something that don't make sense in the community, just because there is a tax in the open source and community where you have to develop tests for all those systems. You have to, it means that all the testing that goes on in the community has to account for those, even if they're using, maybe some proprietary software, from, say, Oracle or other folks that may require different licenses and things that may not be available to the community when they're doing the standard OpenStack testing. So those things that may show up in enterprise. But again, we are interested also when those things become mainstream and are the community is driving those, moving those capabilities back, and even all the way back in terms of the ease of use capabilities, as much as we can, giving those back to the community as well. So I think it's a very dynamic cycle, and it's kind of an interesting one where being very active in the Trove and the OpenStack communities, but at the same time trying to innovate and drive new functionality as quickly as we can, and delivering a product that will make a very seamless user experience when people are adopting the database as a service and implementing it in their own environments. Just again, so there's details here. I won't spend a lot of time here, but just in terms of looking at the capabilities that are there. And this is going to be one thing I'd say is that this slide's going to be very dynamic, because again, replication was something that came out in our first edition of the Enterprise Edition of the Database as a Service. But now with Juno, that's moving back into the Community Edition. So, again, over time, those things are continuing to move forward. The web-based management is something where, again, we're moving aggressively there, because that's something where we think a lot, making it easier to manage and do that graphically is something that we're adding more features in the Enterprise Edition. But then as it makes sense to move those back into the community, we'll do that as well. Again, as I mentioned, trying to be very sincere about making Trove better, not just making the Tora DBaaS platform better, but both, of course. Another thing that we found, and I've kind of alluded to this a little bit or referred to it in terms of the support for different database vendors. And one of the challenges is, as we've talked to enterprises that are looking to adopt Trove, one of the challenges they have is they want to make sure that the databases that they want to adopt, the database technologies and vendors that they want to work with, they want to make sure that those work in all the OpenStack distributions that they're or whatever OpenStack distribution they've standardized on within their organization. So whether that's Red Hat or HP or Mirantis, they want to know that the database that their choice of MySQL or MariaDB is going to work in that environment. So that's, I think, really a key thing where people want to have that assurance. And so therefore, as to Tora, another key thing that we've done recently is introduce our database certification program, where we have a continuous integration environment where we're actually testing all of the databases in all of across all these supported OpenStack distributions and verifying that there is the ability to have this cross-testing and having this all work seamlessly. And in particular, this program actually, I had mentioned earlier about our guest images that are available for the supported databases, and those are all supported. We're basically using those guest images to test them, so that they work out of the box. So once you install it, it's going to work directly, not just you don't have to go through an effort of building the image and trying that out first. Moving forward, and this is again, some of those folks are folks that we're working with today. Some are still works in progress. And I think right here you can see one of the things we've tried to do with the database for certification levels as well is try to start characterizing what does it mean to be kind of a basic level of support. Because again, one of the things we've seen in the community is a lot of the time the community members will implement initial support for a database server, and it's very, very common. Actually, many of the servers that are supported today are just at the basic level of support where people just want to do basic provisioning and resize. So that's something where there's a basic level of support there that gets you started. For development and test, that may be a perfectly reasonable way of supporting that. And we do, I'll add, as to Tora, in our versions, we do support those databases, and we'll, in terms of our support and SLAs that we deliver, whether it's the basic, intermediate, or advanced, so it's not a SLA distinction, but it's a capabilities distinction. So again, you may be wanting to roll out a database as a basic level of support into your organization where you're supporting development and test use cases, but then be able to bring it up to intermediate or advanced over time. And really, again, right now when you're looking at the IceHouse or Juno timeframe, the advanced support is specifically on MySQL, and we expect that to evolve over time. But right now, it's MySQL and the flavors of that are really in the advanced state, whether it's Percona or MariaDB. But over time, we expect to see progression. We're seeing progression already towards that with things like MongoDB as people are moving that further and further down the pike. So finally, kind of why Trove? Just to summarize a bit. Again, as I said, databases are different. They require different skill sets. They have a lot of requirements for data resiliency and replication. The data is valuable in the databases, so that's another key thing. Trove is different. Again, it's a layered service. It's a capability that brings in things on top of that. And really, as to Tora, we're really trying to make that easy. We're trying to make it easy for people to roll out these Trove and implement it in their environment so they can deliver that user experience of self-service databases to the people in their enterprise that need databases and want database on demand. So we're really trying to make it easy and robust and interoperable with all those underlying databases that are supported. So with that, again, I think right now, if you want more information on Trove, I mentioned earlier that we had our Trove Day, and this slide you can see here, you can get information about that. If you need to contact me or Tesora or other folks at Tesora, you can see where you get that. One thing is again, as with any OpenStack project. The wiki and the IRC are open. Feel free to join in the dialogue, join on the project. We're always looking for more folks to join in and participate with us in Trove and move it further along. But if you want to just sort of get started and start looking at Trove and start adopting, there's some links there to get to Tora, and we try to make it a little bit easier to consume. As I said, that's kind of one of our big missions right now, is to try to make that easier for all of you to get started with Trove. With that, I think so. That's kind of the story. Raphael, I don't know if you had any questions that had come up from you or from any of our participants today.
Yes. So actually there came a couple of questions in. So Ken, thank you very much for your presentation. The first question, I will walk through them in chronological order. The first one is Trove an independent database as a service, or is it an API set to front other databases?
Yeah, good question. And maybe I'm not sure when that came in, but hopefully maybe some of that came across as we talked through it. But yeah, it's just to service other databases. So, and one of the things too that I think is important is Trove it's also just on the control plane, right? So it's just about managing the databases and manage the life cycle of the databases. It doesn't get involved in the data path. So if your application relies on MongoDB and uses the APIs of MongoDB, Trove will help you manage MongoDB and give you that same API. You're still interacting directly with MongoDB. Likewise, if it's MySQL, if you're integrating with if you're using Trove to provision and manage the MySQL servers in your environment, you're still going to interact with that at a data tier using the standard MySQL APIs. So again, it really takes advantage of all the great technologies that have been built, and the innovation that's gone in the database space over the past number of years.
Okay, so the next question is, what is the underlying operating system that Trove uses to launch the guest agents? Yeah, so the way it launches those guest agents, it's actually taking advantage of Nova. The way that we put it together is actually it puts those guest agents on the images, on the guest images. So you would have, for example, if you had a Cassandra instance where you would have the Cassandra server and a guest guest agent. Those would be, we build a guest image with those components along with anything else you needed to support that implementation. And then Nova would launch that. So again, it could be running, we actually have images that would be running either CentOS, it could be running the Ubuntu underlying operating system within that image. But at some level, it doesn't really, that's almost kind of irrelevant to the person who's requesting the image, because they're going to get a connection endpoint where they're going to be talking to the database server using that standard database server API. So mostly they're not even going to be aware of what the underlying implementation of the operating system is. In fact, Trove can also take advantage of container technology as well, because it's taking advantage of the way the underlying Nova is configured and the facilities are there. It's great to have that kind of layering so that Trove doesn't have to reinvent the wheel. It can take advantage of the capabilities that are coming out with Nova on this compute side and Neutron on the networking side, and really presenting those up through the stack. All right. What are the missing pieces in Trove that the Trove community is currently working on? Sure. And again, I think one of the big things I touched on a little bit is I think a big missing piece is just actually going a little bit more breadth first, maybe, than depth first. I mean, we're doing a lot of work on MySQL, and that is a very popular database for people to be adopting Trove, and one of the early ones. But certainly people want to have the same quality of service and the same level of service across MongoDB and Cassandra. So we need to be able to implement all the backup and restore features. We need to be able to implement
all the clustering features, all the replication capabilities. Further support for replication and clustering, those are other things that we're working on in the roadmap and taking MySQL even further. But again, I think one of the big things is actually broadening the support across all the databases that are already supported, and then adding more databases. I mentioned some of the enterprise databases that aren't currently supported, but that we talk to people every day about, things like Oracle or DB2 or SQL Server, where people are looking for support for these databases that they rely on every day. They want Trove to be able to provision those as well and have Trove be able to help them manage those systems so they can do that in a consistent way.
Are there guest agents implemented in containers like Docker, for example?
Yeah. So right now, so Trove can again take advantage of the underlying agent, the underlying Nova support to be able to use things like containers and Docker. Right now, the guest images that we've developed are not taking advantage of right now, but that's something that we've been looking at, and definitely something that we've been looking at expanding our testing into that space. Because that's, I probably should have mentioned that too as one of the areas where Trove where we're actually actively working on Trove, because obviously the containers will provide lighter weight support and the potential for less overhead. Actually, my understanding, and I'll apologize because I'm not directly involved in the use of it at Rackspace. My understanding is actually Rackspace is taking advantage of containers in their public cloud implementation of Trove. So we do know that that's a capability that's out there, but making, again, as to Tora, trying to make it easier for people to adopt that and use that approach is something that we still have some work to do on our side to confirm that and actually certify the ability to use those environments.
I think the last question, or the last two questions for today, are what are the common misconceptions around Trove?
I think one of the big ones that we hear a lot of times is Trove is really just MySQL, and it's not. As we talked today, I think one of the most exciting things about it is it's not just MySQL. It's not just RDS for OpenStack. It actually is a combination of RDS and Redshift and DynamoDB, and you can think of it as all of those things combined. And it's I think that's a great thing about Trove is it gives you a consistent management plane where you can actually create a consistent view of all those different database technologies and provide a way of managing it. I think that's one of the big ones. Another one, as I kind of alluded to earlier too, is it just provisioning? And no, it's not. It's actually giving you full lifecycle management. And I think that's something that we see people and I say that's a misconception, but in some of the early basics, some of the data stores that are supported at just a basic level, it is just provisioning today. But that's something that is growing and expanding over time. And then the third thing I'd say in terms of a misconception is many people say, oh, is it another database? That came in as one of the questions that was asked earlier. Is it a new database or is it management for other databases? And again, I think that's a key one. Again, it's something that it lets you really take advantage of a lot of the innovation that's gone on in the database space today by giving you access to the databases you're already using and the ones that you want to start adopting.
Thank you so much, Ken.